BSU University.
Welcome back. For this week's video, I wanted to continue the Science Fundamentals series and cover scientific notation. Scientific notation is a way to write really small numbers or really large numbers in terms of their order of magnitude. So you see the list here on the left is how you write large numbers. You have a 10 to the power of 0 through whatever, and what the power tells you is the number of zeros following a 1. So 10 to the 0 is obviously going to be 1. Anything to the 0 power is 1. 10 to the 1 is just 10. 10 squared is 100. So 1 followed by 2 zeros, and then 1,000, 1 followed by 3 zeros, and so forth. So you'll see here there's some common prefixes that you've encountered. With 1,000, it's kilo. With 10 to the 6 or 1 million, it's mega. And then you have giga and tera for 10 to the 12. And those will just keep going. So you'll see that it's a lot easier to write a 10 with an exponent versus trying to keep track of all the zeros, writing the numbers out. And then here on the right side is how you write small numbers. And your exponent is just going to tell you the number of spaces to the right of the decimal that you place a 1. So 10 to the minus 1 is just 0.1, 10 to the minus 2 is 0.01, and so on. And so 10 to the minus 2 is, the prefix is commonly known as centi, for like centimeter or centigram, which I've never seen used but exists. And then 10 to the minus 3 is milli, 10 to the minus 6 is micro, and then nano, pico, and femto. And those will just keep going. So again, you see it's way easier to just write an exponent instead of writing the number out. Alright, so I just wanted to show a few examples of going from the number to scientific notation, and then a couple examples going from scientific notation to numbers. So to write 108 in scientific notation, you know it's 100, so it's 10 to the 2. So you'd write 1.08 times 10 to the 2. Because the 10 squared is going to move the decimal place 2 spots to the right. Then 35,220. You just write the decimal after the first number, so 3.522. Leave out the 0. If you know anything about sig figs, you'll know that the 0 is not significant. But you'll see after the 3 there's 4 spaces, so it'll be 10 to the 4. And then for 0.00299, you write 2.99, and that's going to be times 10 to the 1, 2, 3, so minus 3. And then 15 billion is just 1.5 times 10 to the 10, and then 0.00000008338. Just write 8.338 times 10, and then just count the decimal places, so 1, 2, 3, 4, 5, 6, 7, so it's 10 to the minus 7. 4 is just going to be 4 times 10 to the 0. And now to go back to the number from scientific notation, for 1.391 times 10 to the 2, you just move the decimal 2 spots to the right. So this would be 139.1. And then for this last one down here, see that it's 20.34. Typically, you only have the decimal after the first number, but the concept should still work. So you're just going to move the decimal place 3 places to the left, because it's 10 to the minus 3. So you know you have 0.02034, and that's your final answer. Now to finish out this video, I just wanted to go through a list of common things that you've heard of in your life and see what their mass is in terms of kilograms, so you get an idea of why scientific notation is so much more useful to write these numbers. Well, most of them at least. Anyways, so the mass of the Earth is approximately 6 times 10 to the 24th power. So 6 followed by 24 zeros. The mass of a ton is approximately 9 times 10 to the 2 power, so about 900 kilograms. The mass of an adult male like myself is approximately 7 times 10 to the 1 kilograms. The mass of a bacteria is around 9 times 10 to the minus 16 kilograms. The mass of a carbon atom is about 2 times 10 to the minus 26 kilograms. And last we have the mass of an electron, which is about 9 times 10 to the minus 31 kilograms. So you can see for yourself, way easier to write with exponents versus writing out giant long numbers. Class dismissed.